Okay, so let's get started. We're going to be taking a look in this training module at working with our alternator control programming for our Gen 3 Coyote engines. Now we jump into our alternator control programming for forced induction, and we want to get a little bit better charging voltage when we're under higher throttle boost situations. We have the ability to ramp up our charging voltage so that we get a bit better spark energy and the potential for a little bit better fuel flow from our lift or low side pump. So these are two things that we definitely want to consider. If you're naturally aspirated, basic bolt-ons, there's really not a huge benefit or really any benefit at all by ramping up your charging voltage under higher load full throttle situations. So pretty much always do this for forced induction engines only. Let's jump in, take a look at a stock equivalent file. We're going to learn where we can find our alternator control programming. We'll talk about the tables and the settings we may want to change. And then we're going to take a look at a data log, which is going to help us figure out where we want to get into the higher charging voltage at. Because the programming here is based on fuel flow rate, we need to go and look at our individual car, depending on the fuel system we have fitted into the vehicle, where the actual fuel flow rate lies and where we want to have the voltage ramp up. Let's jump in here and take a look at a few things. I'm going to go into our file. I'm going to go to open, and I'm going to go into our desktop. That's where I have the training course folder on this PC here. I'm going to jump in to the sample calibration file subfolder and then select any of our stock equivalent files here to take a look at. So let's jump in here to 2020 Mustang GT Auto Stock. Give that a second to load here. And we're going to move in to our calibration file. We're going to jump in here to our Systems tab. Under System, we're going to move here into our General tab. Under the General tab, we're going to be looking here specifically at our alternator control, which is found right here. Now, the alternator control on our Gen 3 engines is going to be a pulse width modulated type of control, and it's going to be a closed loop control. What that means is the battery voltage, obviously, if it had no alternator charging against it, it would sit, let's say, roughly at 12 volts. That could be a little bit lower, could be a little bit higher, but roughly 12 volts. When we're running our engine, idle, part throttle, full throttle, we want it to charge at a higher battery voltage. The standard is about 14 to 14.5 volts. So the system works looking at the desired charging voltage that we specify from any of these tables here. We have different conditions we might enter in and out of. The two tables that we primarily use would be the normal output and the high fuel demand table. In here, just pop into the normal table. This is going to be specifying what we want the charging voltage to be at. The system is going to take a look at what the battery voltage is. It's going to take a look at what the desired target is going to be, and it's going to ramp up the alternator control to maintain and hold at the target. It does this with a pulse width modulated type of control system. It's a 0 to 100% duty cycle output to the alternator, so it's constantly adjusting the duty cycle control to adjust the voltage regulation going on within the alternator. The nice thing is here that we don't have to go in and program any of the PID closed loop gains in the background. That's taken care of for us already in the programming from Ford. All we need to do is set the desired target voltage within one of our tables here so that it charges at that desired voltage. Now, when we're talking about performance out of our engine, we want to go in and potentially ramp up our voltage under higher throttle, higher load situations. We're not interested in running any higher charging voltage at idle and part throttle conditions. This is going to be kind of a two-part effect. If we ramp up the voltage too much at idle and part throttle, it's going to be probably causing the alternator to get hot over time.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.